Hey, so I realized that I left off a couple of pretty important things in the first kinetics video. So I just need to actually tell you what it means to be zero order, first order, second order, or third order. I need to explain what that means. And I'm going to go in further detail about the units of K. So this should be very brief. Okay, awesome. Share, share. Share and share. Okay. So let's start by, what do we say? We're going to look at orders of reaction. Okay. So if what we said was the order of the reaction explains how, or shows how concentration changing affects the rate. All right. So if it is determined that it is zero order with respect to a reactant, what that means is the concentration does not affect the rate. Okay? Zero order. It doesn't affect the rate. Therefore, it is omitted from the rate law. Okay? So if there is a reactant that is not present in the rate law, then you know that it is zero order with respect to that reactant. If it is first order with respect to a reactant, well, that means that there is a direct correlation. There's the direct relationship between concentration and rate. Okay, so let me show you how you can figure it out. We know that the concentration here is first order, right? So let's double. Here's, if the concentration is 1 and 1, then the rate is 1, right? Now, if we were to double this, the concentration becomes 2 over, double the concentration, right? Double the concentration to the 1 equals 2. So we see that the rate doubled. If we were to triple the concentration, right, we would see that the rate would triple. Okay, so they are directly related. I hope that made sense. Let's look at a second order reaction. Well, now we're going to have a factor of 4, right? Pretty sure. Let's look at it. So let's say that our concentration is 2 and it's second order. Well, that gives us a rate of 4. Let's double this to 4 squared because it's second order, 16. So we increased by a factor of 4. So that when the concentration is doubled, the rate is increased by the factor of 4. Okay? Or we could cut it in half. So 2 squared equals 4. Cut in half. We have 1 squared equals 1. We see that it decreased by a factor of 4. Okay? So that's how it's related, second order. Let's look at third order. All right. Well, let's say that we have a concentration of 1 and it's third order. That gives us a 1, okay, as our rate. Let's double and make it 2 to the third. And isn't that 9? 2 times 2 is 4 times 2 is 8. That doesn't make sense. Something's wrong. Let's what am I doing wrong here, y'all? Okay, let's do that. Factor of 8. Let's do another one and see if my brain goes back. Let's double the 2 cubed to the 4 cubed. 2 times 2 times 2 is 8. Okay. 4 times 4 is what, guys? 16 times 4 equals what? 48. 16 times 4. Losing my mind. 64. Okay. So here we increased by 8. Just wanted to make sure we had some consistency, right? Because I'm an old lady. And I make silly mistakes sometimes. Increased by 8. Okay, so if it's third order, it increases by 8. Tell me if I'm doing something wrong. Okay, that's how you would figure that out. That's how you would figure that out. I could cut it in half. Oh, I know the one I was thinking of. If like it was second order, right? And we maybe we triple it. It goes from a concentration of 2 squared equals 4. We triple that to 6 squared. 6 times 6 is 36. Yeah, that's times what? 9. And then there would be a 27 one. Anyway, so I hope you understand what I just went over. If not, ask in class. But obviously, or hopefully you can see how to figure it out for yourself. What is the effect on changing the concentration? We'll just plug it in. Let's look at our K values. All right. And okay, it has to do with the overall order, right? And there's a trend. This one is normal. It's moles per liter second. Normal. So we're going to start normal. Now we're going to go to first. We're going to remove 1 mole per liter. And that's going to leave us with a per second, right? Or a per second, or a per second. Okay, now we're going to go to second. We're going to, sorry. Okay, I'm going to go second is 2 minus 1 equals 1. Therefore, 1 upside down molarity. Y'all, I'm just telling you how my brain, I can see it mathematically, but I try to create a way to show you. That's my up down side molarity. And it's still got the seconds on bottom. Okay, now if it's third order overall, I'm going to do third minus 1. That's 3 minus 1 equals 2. Therefore, 2 upside down molars. Right? So that's L2 over moles 2 per second. Right? You could do M2 negative, S negative, M2 negative per second, All right, so hopefully you see the trend there. You can see it doing the math, but if you don't, so if it's fourth overall, I'm going to go, and I'm done here. Fourth minus 1 equals 3. Therefore, 3 upside down molars. M's, right? L3, MOL3 per second. Boom. That's all you got to do. See ya. Excuse me.